Welcome to section 4.1, our very last section of the class. This seems like a strange way to end it all with us doing video lectures, but it's the way it had to be done. So I hope this has worked out okay for all of you, and I hope to see you around campus again sometime. All right, let's continue on with section 4.1. So what I'd like you to do is I'd like you to read the question, pause the video, read the question, and then we'll go ahead and answer the question. All right, so I don't know what you answered, but the answer is relationships. All of these involve relationships. And that's what graph theory is all about. It's a mathematical theory that deals with the mathematics of relationships. So here's an example that'll help us to understand what we're going to be doing. One of the most famous applications of graph theory originated in Königsberg, Prussia during the 18th century. The Pregel River divided Königsberg into 4 distinct sections as shown below. This is called the Königsberg Bridge problem. Okay, so if we look at the picture, here's our land and it's, marked, and then the little white strips are the bridges. It says 7 bridges connect the 4 portions of Königsberg. It was a popular pastime for the citizens of Königsberg to start in one section of the city and take a walk visiting all sections of the city, trying to cross each bridge exactly once and return to the original starting point. Okay, so you have to cross each bridge once. You have to visit each pieces of these land, and you have to start and end in the same spot. So what I want you to do is I want you to get out your classwork and I want you to try it, okay? So just try the first example and then tune back in and we'll talk about it. Okay, so if you take a look at what you were supposed to be doing there, you were attempting to walk this. So I'm going to just start here. Okay, so if I start here and I cross this bridge and go to this piece of land, then I cross this bridge and go to this piece of land, and let's say I go all the way here, cross this bridge and go to this piece and continue. So you can see what I'm doing here. Okay, now, so I started here, start right there. Okay, so my problem is when I get to here, if I'm going to somehow get back to this bridge here, I'm going to have to cross back over this same bridge. So that's not going to work. And, you could have tried different ways of, maybe going here, but then you would have had to go, any way you try to do this, you're going to have a problem. Okay. You missed a bridge. All right. So what I want you to do now is I want you to try this problem and see if you can answer this problem. So go ahead and pause the video and try it and then come back. Okay, so hopefully you tried this and you see here if we start at A, let's say again. Okay, we start here. And then suppose I go, and there's different ways to do this, but suppose I go this way. Okay, so I'm headed that way, and suppose I continue on this way. So I'm going that way. And then I go here, that way, and then here, this way, and then here, this way, and then here, this way. Oh, I've got a problem, so I ended here. If I want to continue on to pick up this piece, I have to recross it apart. So that's not going to work. So the question is, between these 2 models, what did you find easier? That's up to you. The model is supposed to be easier. Whether or not it is, I don't know. Okay, so let's go back to another classwork problem. So I want you to go ahead and try these. You're supposed to be placing your pencil on any one of these points here and see if you can trace the figure completely without lifting your pencil and without tracing any part of that line twice. So go ahead and try this and see if you can do it on both part A and part B. Pause the video. Okay, so hopefully you've tried that, and when you did this, hopefully you found that sure enough, this first one is pretty easy to do. Okay, so we're able to do this. So the answer is yes, we can do this one. Okay. What about this one here? If we start at, let's say A, if we started, I don't know, I'd rather start here. It just makes it easier to see. If we start at C, we can go all the way up to A, going this way. And then we can go all the way down here and get to D. But then we're to a dead end point. How do we pick up this piece here? We can't. Even if we, try to do it like this, we would have to retrace. So this one we cannot do. Okay? So why can you trace one and not the other? Well, you can sit and look at these and think about why it is, but it might be taking you a while to figure this out. So we're going to learn some of the things. Gauss is the one who figured this out. We're going to learn some of the things that will help us get to that path. So let's go back. So right now you might not be able to answer that, and that's fine. Let's go back to section 4.1 handout, and let's look at some definitions that are going to get us on the road to figuring it out. So definition, a graph consists of finite set of points called vertices and edges, which are lines that join the pairs of vertices. So when we look at this, this is a graph. So what does it consist of? All of these little dots, these points, okay, that are called vertices. So we're supposed to list them, list the vertices. So vertices. That would be A, B, C, D, E. So A, B, C, D, E. Okay, and then we're supposed to list the edges. Okay, and the edges have to be listed with the two endpoints. So like if we start here at A, we'd see we have one that's AC. So let's go ahead and list that. And then we have another that's, might as well keep them in order, AB. And then another AD. So the easiest way to keep track of that is to think there are three things coming out of A. And do we get all three? Yes. Okay, then move on to maybe B and say, well, did we get all of B? Well, we already have AB. We don't have to relist it as BA, but we do need BC and BD. Okay, so BC and BD. BC and BD. Okay, then we're going to go on to C and see if we've got all of those. Well, we have CA, that's an AC. That's one that comes out. We have CB already, that's BC. But we do not have CE, so let's get that one, CE. Okay? Then we move on to D. Do we already have DB? That's sticking out of there? Yes, DB is BD. Do we have DA? We do, AD. We do not have DE. Okay? And then finally with E, what does it hook up with? Well, EC and ED. So we've already got those two. All right, so we've got all the edges for that one. Let's move on to the next one, okay, and get all of them here. So the vertices here would be, let's see, still A, B, C, D, A, B, whoops, C, D, E. Okay, and then our edges. Okay, so the edges are going to be, we're going to start off with, what do we have? We have three coming out here. So I'm going to keep them in order again. I'm going to say AC, or no, I'm sorry, AB would be first, then AC, then this is AD. Okay, then go on to B. BA, we already have that listed. BC, we do not have that one. And BD, we do not have that one. Okay, then we're going to go on to C and look at that one. CA we have, CB we have, we do not have CE. So let's get CE. Then we're going on to D. We have three coming out of there. We have DB already listed. We have DA already listed. We need DE. And then we go to E. We have two, CE and DE, and we've already got those. So what I want you to notice is when you look at these two, they have exactly the same vertices, and they also have exactly the same edges. Notice 1, 2, 3 with A, 1, 2 with B, 1 with C, and 1 with D. They have exactly the same edges. So even though these graphs look very different, they represent the same thing. Okay, they represent exactly the same graph. Now, one thing I wanted to point out is you might have thought when you were doing this, A goes to C. We didn't write AE, and why was that? If we had AE, we would have a separate piece coming out here, okay? So the only way we can get to E is from A is go, well, one way is go from A to C and then from C to E. We do not have a direct path from A to E. That would have to be something like this, okay? So notice how we wrote those. Okay, that concludes page 1.